This video is intended to provide explanation of how to calculate variance and standard deviation for a small set of numbers. The data that we're going to be using are the variables that we used from our first homework. We have 5 scores for ages, and our task was to calculate the variance and standard deviation for these 5 ages. The first thing that we do when calculating variance and standard deviation is to calculate the average or the mean for those set of numbers. So when we add up 20 plus 21 plus 22 plus 21 plus 19, and we divide that sum by the 5 scores we have here, we end up with an average age of 20.6. So what we are trying to do when we determine variance and standard deviation is to try to get a sense of how far on the average our scores spread out away from this mean of 20.6. So we know that this person who was 20 years old was 0.6 of a year, 0.6 below the mean. So the first thing that we do is we calculate what's called a deviation score. The deviation is just the difference between the observed score and the mean. So we subtract the mean from every single one of our scores. Again, what we're trying to figure out is how far on the average scores spread out from the mean. That's what the deviation and the standard deviation tell us. So this first person was 0.6 of a year away from the mean. This next person was 21 years old. They are 0.4 of a year older than the mean. 22-year-old is 1.4 years older than the mean. The 21-year-old again is 0.4 years older than the mean, and this person who was 19 is 1.6 years below the mean. Again, what we're trying to figure out is how far on the average scores spread out from the mean. So ideally what we'd be able to do is just to find the average of these deviations, since these deviations are telling us how far each individual scored away from the mean. The problem that we have is that when we sum these numbers up to get the average, we end up with a sum of 0. So if we're trying to figure out how far on the average score spread out from the mean, we know that there is spread. We can see that spread. The average is 0 because we have a balance of our negative and our positive values. To address this problem, what we do statistically is that we square each one of these deviation scores, okay? Because we're wanting to get rid of the negative values that create this negative and positive balance. So by squaring each one of these terms, we get rid of the negative terms. So we have negative 0.6 squared is 0.36. 0.4 squared is 0.16. 1.4 squared is 1.96. 0.4 squared again is 1.16. And negative 1.6 squared is 2.56. We can now take the average of these squared deviations. So when I add all of these up, I end up with a sum of 7.2. That is 7.2 squared years, okay? Because the scores were in years, the average was in years, the deviation was in years, but now we have squared those numbers. And when you square the numbers, you also square the units. So we are now talking about a sum of 7.2 squared years, which doesn't make a lot of sense. We take the average of that, which gives us an average squared deviation of 1.44 squared years. The average of these squared deviations is the variance. Okay, again, the challenge though is that this is 1.44 squared years. So it tells us that on the average, the 5 people that we have here fell on the average of 1.44 squared years away from the mean. That is hard for us to interpret, so what we do is we try to get rid of that squared unit, and we do that by taking the square root. So the square root of the variance of this 1.44 gives us the standard deviation. The standard deviation is in the same units that we started with. So when we take the square root of 1.44, we now end up with a standard deviation of 1.2. That tells us that on the average, scores spread out from the mean by 1.2 years. The issues that we have to keep in mind are that while standard deviations are in the same units as our scores, mathematically and statistically we can't break down the standard deviation in order to explain why everybody didn't score exactly at the mean. The variance does allow us to do that. So when we talk about, when this course, we're going to be talking about t-tests and analysis of variance and looking at correlations and things like that, they're all going to use variance instead of standard deviation because of the mathematical properties. But I want you to understand that that variance and standard deviation are both linked. Now, one of the other things that you'll be seeing as we look at SPSS and other books that you might be reading is that you'll see the term used of mean squares. That capital M, capital S, or mean square, that actually means the average, the mean of the squared deviation. So when they say mean squares, they mean the mean of the squared deviations. Therefore, the mean squared is the variance. One of the things that's going to drive us a little bit crazy about statistics is that we have a lot of jargon that sometimes means the same things and sometimes means very different things. And I want you to be aware when you see means squared, that means variance. It means the mean of the squared deviation. When you see the term sums of squares, it is the sums of the squared deviations. So all of that stuff comes from the same basic calculation. It's really important that you understand how to calculate variance and standard deviation, specifically calculating variance, because everything else we do with t-tests and ANOVA and correlation and everything else is going to be based on this issue of finding the deviation and then squaring that deviation and then taking some type of average of that squared deviation to get an estimate of the variance within the set of data. I hope this has made some sense.